Hey everyone, thank you so much for checking out the Weaviate podcast. Today is going to be truly one of the most special episodes of the Weaviate podcast we've had so far. Laura Ham is making her debut on the Weaviate podcast. Laura has created so much amazing content that helped me personally learn how to use Weaviate and all sorts of things from Weaviate examples to say the design of the GraphQL and blog post tutorials around this graph-like data model and all these exciting things. So Laura, thank you so much for coming on the Weaviate podcast.
Thank you, Connor. Yeah, it's great to finally be in your podcast.
So could we start with the introduction of kind of the origin story of what led you to be working on Weaviate?
Yeah, that's a good start. So that goes back already like 5 years, I think, when I started working together with Bob, the one of the founders of Semi and Weaviate. Yeah, back then we were working both as a freelancer on some other projects, and Bob started working on Weaviate. And I think like we were both super interested in natural language processing and how like all the developments in that world happened. And that's where, yeah, we started collaborating and yeah, started working on Weaviate basically.
So I think Bob tells us when I asked him how he first got into this, he says the king minus queen plus man, that kind of thing. Was that a similar inspiration for you that led you into this vector embedding kind of part of natural language processing?
Yeah, definitely. So at the time you had like these first word-to-vec models, for example, coming up. And with word-to-vec, of course, words are represented as vectors. And that's also where you have this king minus man plus female is queen thing is coming from, of course. So basically, with these algorithms like Word2Vec, we were like they allowed us to use neural networks to understand language and word associations. And yeah, what's been really interesting to me specifically is that you can calculate then like how similar different words or different concepts are to each other. So you can find synonyms or related concepts, which is of course very relevant if we talk about a search. Because I think like before with natural language processing applications, people were working or still working a lot with ontologies or taxonomies. And think like ontologies and taxonomies, they need to be defined beforehand, so before you start using an application. And I see the potential problem or challenge there is that there is also always one or more people defining this ontology or taxonomy, and they have to agree on some meanings of words because in an ontology you have a word and you have the context of the word or what it means. So people have to agree on this meaning, and that's really hard if you work with a lot of people. Yeah, basically, if you then you don't know how to deal with synonyms, or yeah, you basically have to deal with, okay, I want to give the best search experience to a user, so you need to know what kind of words he or she is using um, as an ontologist. And I think this is one of the problems that algorithms like Word2Vec or like the BERT models today with neural networks can solve.
Hmm. Yeah, I'm really excited to dive into the ontologies and yeah, I remember another story Bob had told about they couldn't agree whether it's a sea or a lake and that kind of idea where you have the disagreement on the terms and going to New York with you and seeing the ontologies, the symbolic graphs. I had never really been exposed to that kind of thing before, but quickly I want to dive a little deeper into your 5 years at Semi Technologies and Weaviate. Can you tell me about sort of the and then we'll kind of get deeper into how Weaviate itself has evolved. But how has your experience with the kind of startup company growing? How has that been?
Yeah, that's been great. So like 5 years ago, I started more in a research-like position. So I was looking at technologies like Word2Vec and how can we use that to build a good neural search experience, basically. So I've been experimenting a lot, building a lot of prototypes to test. And what's good to mention, I think, is that I've been working with like real users or real customers from the start. So we really learned from them what their challenges are and like how we can solve them and test things out. So yeah, it was really more like a research position. Back then, I was also still studying. I was doing a master's degree in human-computer interaction. So that also, like the lessons that I learned in my studies, I could directly apply in the research that I did with Weaviate, because my goal was to make the search experience, or the user or developer experience of natural language processing or search engines as friendly as possible. So it was really good that I could put it in practice directly. So, and during that time, like, of course, the startup started to grow. So Weaviate got developed until like the version 1.0 we had like 2 years ago, I think. And since then, the team has also been growing, and that's just really amazing to see. So yeah, during that time, I've also been doing a lot of talks at conferences. I've been in close contact with the open source community, so always like trying to grow the community, learn from their feedback that they have, and yeah, since I was involved in improving the developer experience, I, for example, designed the whole GraphQL API that we still have today, and the documentation that is still out there. Yeah, those kind of things. And then now that the team is like way bigger, I can focus more on like uh, yeah, one thing again, and it's more like the research. So that's really exciting.
Yeah, that's so interesting, and I'm really curious. So, could we dive a bit more into the human computer reaction and the user experience, the GraphQL design? I love how it has this, like Weaviate has this get, and then you can chain on these functions. Like if you want to do the near text search, the near vector question asking, and then accessing the properties of your data. Can you take me through the design of the GraphQL and maybe principles from human computer interaction? What that kind of field of study? How does it help you think about these kinds of things?
Yeah, super interesting. So yeah, first I will take a step back. So first, I want to share why we have GraphQL. So because we also have normal RESTful API endpoints, and but those like REST API endpoints are more for accessing the resources, so accessing the data, so updating data, uploading data, um, deleting data. You can all do those kind of things with RESTful, but then if you want to start searching through it, you need you cannot um, do it in one single URL query basically. So that's, I mean, the user experience of doing a search in a RESTful like way, it's really hard. So that's why we started looking at GraphQL basically. Um, and yeah, of course, like when I started designing it, my first goals were, the general design principles that you should have with API design, like it should be intuitive, should be readable, um, simple as possible, like consistency in terms of naming, etc. Um, and then I started designing, and then I thought, okay, we're building a search engine which works, for example, with semantic search in text or images. But so I wanted to also give a nice experience when you write a query, that it feels like you're writing it in natural language, and that's where the get, and then near text, and then like the class and properties come from, because you can really read it as, okay, I want to get uh, a data that is of type article, and from that I want to see the name, the content, the authors, and so on. And I want to find articles that are near this piece of text. So I want to, I try to integrate the human language as much as possible in there.
Yeah, well, that was really well said. I really like the flow of it, and that also helped me understand sort of the difference between the REST API and the GraphQL API. If you want to have like arguments to a REST API, you have to have like this long URL, right, with like the question mark and that kind of thing,
Yeah,
compared
exactly.
to
Yeah,
compared to like stacking it out with the GraphQL, right? Yeah, it's really
yeah,
interesting, the idea of a natural language interface with a search engine on, say, like multimodal data, arbitrary data, where you could say, "Give me a picture of a dog playing with a ball." I don't know, but like that kind of natural language interface experience. So, could we then kind of transition a bit to so when you have the GraphQL and you have the new UX, how does that tie into the vector database of Weaviate and all the indexing stuff, and how does the whole team kind of coordinate that kind of thing?
Yeah, so right now we have like a big Weaviate core team, so like consists of core engineers who are really building Weaviate. And next to that, we have like the research team that you and I are in. And yeah, so the goal is to have like we do research, like we find new technologies that might be a potential new feature or like an improvement or something. And our current approach now is that we pick up these things, we test if they are useful for us. We do like experiments, yeah, to evaluate it, and then the goal is to come up with a good design for which we can pass on to the core team, let's say. And this design that consists of um, yeah, what this technology is, but also how it should look like from a user perspective. Um, so how it should be used by a user. And yeah, that's a really important thing that we find really important with building Weaviate, is that we always try to have the highest UX as possible. So um, that means the design is from an API perspective, because Weaviate ends at API level. So all the things that the user or developer using Weaviate will see is at API level. So this is the user experience. And from there, we start building a design basically. And yeah, so once we have that, we can pass it to the core team and they can start building and do it like in the most efficient way, of course, and so on.
So when I want to ask about your approach to the research process, and when you see new papers or new ideas coming out, do you instantly have this perspective of, okay, what would this look like in Weaviate? Is that your first kind of approach to thinking about it?
Um, yes and no. So of course, I'm always thinking about like, can we use this with Weaviate? Yes or no. But it's like I kind of address a bigger question, and that is, does it add value in a search experience? So Weaviate is a vector search engine. So the goal is that people can use this to improve their search experience. So if it's a really nice new technique or new machine learning model or whatever that is not related to this or would not improve the search experience, then I might use it for something else, but not for Weaviate, obviously. So there's always this bigger question in my head, like, okay, can we use this to improve the experience, basically?
Mhm. Can I ask about the development of search and the application of search? Have any particular, say, use cases that you use to reason about most like most problems, say like the question of who's the best basketball player of all time, searching through Wikipedia? Like, do you use these kind of like examples to to like guide your thinking?
Yeah, I think there's always use cases in mind when I think about usability or like for potential new feature. And yeah, this of course can come from my own imagination, but it can also come from what I get back from like open source users or um, yeah, other people that use a search engine.
When you find yourself designing things, do you ever like maybe go too particular into one application and then have to think about how does this generalize out, or is it
Yeah,
design?
that's a tricky thing, right? So it's yeah, of course, like of course you're sometimes I'm experimenting and then you really dive into one subject, but then it's really important to indeed take that step back and then generalize and think, okay,
Mhm.
is this only useful for this particular problem or can it be um, useful in more situations? And both is fine, but you need to be aware of what case it is basically.
You generally have like maybe like less is more. Is that kind of a good way of thinking about how you kind of design these like function calls, almost like when you design like a GraphQL API is kind of like a function. Maybe the more succinctly you can describe it, is that the better way, kind of generally?
Yeah, that's a good way of looking at it, I think. Of course, it should be simple and intuitive, but if you oversimplify it, that's also dangerous. Of course, it should still be clear what it means. And yeah, now that we see that we are adding more and more features to improve the whole search pipeline, basically, this also yeah so another topic comes to my mind now is that how do we scale this GraphQL API to serve all the possible use cases? Before we had like you could use Weaviate for just a semantic search. So that would be a simple query where you have one piece of text or one image that you would search by. But now with all like other methods to increase, like make the pipeline bigger, to improve the search experience and improve the results, basically. The GraphQL should also be be able to support that, of course. And then it becomes really difficult to come up with a good language that supports it, basically.
Yeah, I'm so excited about this idea of the adding new features and building out the pipelines. Quickly before we dive into that, can we talk about, say, what goes into the integrations with, you develop these coding tutorials of how to combine Weaviate with Jina and Weaviate with Haystack. How's your experience been making these like open source tools fit together?
Yeah, that's really exciting. So Haystack by DeepSet and Jina as well are neural search frameworks, which basically means that they focus on the entire ecosystem around neural search. So that goes from like data pre-processing and fine-tuning to the search as well. Um, and those frameworks are like should be used in Python. And that's really nice if you want to build like a whole search experience, right? But if you want to scale this to production or to like big data, then you also need an efficient database that lies underneath this application, basically. And that's, Weaviate is one of the possible databases that supports this. So since I think the beginning of this year, we have these integrations with Haystack and Jina that if you use their framework, you can use Weaviate as its database needed, basically. And that's just super cool to work with these people on this project.
Yeah, I think that's a super interesting connection. Obviously, being like part of Weaviate, I like the vector database end where you have the HNSW efficiently find the nearest neighbor structure with the persistence and the database features, and then you can uh, I- put pipeline that upstream to things like question answering, re-ranking, and overall thinking about these
Exactly.
pipelines. So I'm super excited to dive into this topic of search pipelines. So we have maybe
Hmm.
retrieval, we could have sentence transformer retrieval, BM25 retrieval, aggregate step, and then cross encoder, all these things. Can you take me through your understanding of search pipelines?
Yeah, that's a good question. So how I see it is that like basic information retrieval that comes like that interacts with a database. So if we have Weaviate as database, then a basic information retrieval is just like making a query and getting some results back from the database. Um, this, however, so we use biencoders models, so that are neural networks that make vector representations out of words or sentences, and then like data will be basically retrieved in Weaviate by comparing the vector of a query and comparing with the vectors of the data objects. So this is a really efficient method, but it also comes with some drawbacks that is maybe not as accurate as you want to be. Um, for this, like we also, so next to biencoders that create vectors out of words, we also have cross encoders. So cross encoders do not produce vectors, but they compare a query directly with a sentence or a word and give a value between 0 and 1, how similar it is. These kind of methods, if they are trained on the representative data set, have a higher recall, like higher accuracy than a bioencoder. But it comes with a cost because it's computationally very expensive. So what's interesting now is if we combine this cheap method of bioencoders with the more expensive but more accurate methods, cross encoders. So the idea is basically to have like use a bioencoder to retrieve initial set of data, which is a subset of course all your data relevant to your search query. and then re-rank them, reorder them based on a cross-encoder, which can be executed because it's like a shorter list, basically. So that's one way to improve the initial results of information retrieval. Yeah, and there's I can go on with like more ways. So we have you can all so this was one way of re-ranking results basically. You can go on with that. So if you want to personalize search based on some user information, for example, you could use another re-ranker to re-rank those results again and have the most relevant results to this user placed on top. So you can basically extend this pipeline with many models that you want to have a good search experience.
Yeah, and I love what so I think Bob pitched this idea of having like you're in the ocean and you cast a big fish net and you get a bunch of fish on the boat with retrieval, and then say you have to have
Exactly.
yeah, like workers who pick up the fish, and it's more expensive to have the workers compared to the fish net, but then they're more
Hmm.
accurate at looking at the fish and making sure it's the fish you're looking for. Uh, so one of the topics that really excites me about this is thinking about this kind of zero shot generalization thing and these models that have been pre-trained and they come off the shelf. And with retrieval models, say it's kind of I think like the deep learning end of Weaviate's vector representations are built on these pre-trained sentence transformers that say they have data sets like Wikipedia, where you use the heuristic of neighboring paragraphs, make these representations similar. Or maybe you have like the MS Marco data set where they've published like a million query correct result or like what they clicked on pairs. And so you use that to train these retrieval models. And then it's been trained on such a big data set that you say it will do this zero shot generalization to your problem. And I think this kind of way that we have these pipelines, you see it as a way to say correct the error of zero shot retrieval. So, you know, you're trying to search through, say, the Weaviate documentation, and you're trying to use retrieval from Wikipedia. And of course, there's a bit of a domain shift. So maybe instead of having to fine tune our retrieval model, we could just fine tune the cross encoder, right? Or these kind of things. How do you see this kind of like zero shot generalization of the retrieval and the cross encoder? We could have zero shot cross encoders too. Does it make it like simpler to adapt it to your problem kind of, or like
Yeah, I think yeah, that's really interesting. So I think we need to experiment with that, what works best, because I think if you have the Weaviate documentation, which contains a lot of like specific words to Weaviate, which of course do not appear in Wikipedia, then if you just use this model trained on Wikipedia, it doesn't work right on your technical documentation. I think just just fine-tuning a cross encoder, like retraining a cross encoder, wouldn't necessarily solve the whole problem, because if the results were not caught in this big net of fish in the first place, then the expensive fishman cannot find the right fish anyways. So we also need to make sure that those right fishes are initially already caught in that big net, basically. And yeah, so that might mean we also need to fine tune a bioencoder. Or what's also really interesting is combine it with sparse search. So, for example, BM25, which just looks at so it doesn't use neural networks or anything. It just looks at the words itself.
so BM25 is maybe like a cage, like a lobster cage, like we have like our fish net and we have maybe like some other kind of fishing device. How do you see the interplay of the BM25 and the sentence transformer? I think it's a big question, but like just kind of taking it from the beginning, what does BM25 add to sentence transformers or that they each miss out on?
Yeah, that's super interesting. So I think like before we had just sparse methods, so just TF-IDF, BM25, which just use like exact words to retrieve data. But now, like, of course, these BM25 and TF-IDF methods, they don't know anything about synonyms or polysemy. So that's where dense methods, so methods that are trained with a neural network to understand the language, can solve that problem. But if you just use dense methods like Weaviate is using as we speak, then if you use that on a data set that is not like that is out of domain of your training set, basically, you might see problems. And that can, so then it becomes interesting to combine BM25 like methods with dense encoders to yeah, bridge that gap basically. Because I think like if you have a search query that contains some very specific words, um, like what does near text do in Weaviate? If you want to search by that, then we know that you really need to have the word near text in your result. So if we use BM25 on that query, we will see for sure results with near text. But if we just use that bioencoder, we might see relevant results, but maybe the near text isn't really on top, or like so yeah, if we combine those methods, I think they like can solve a lot of out of domains problems.
Yeah, it definitely seems like they complement each other well, and I think this comes back into the user experience design and how you're going to interface with these two ways of search. So I guess maybe the most straightforward way to do it would be to have, say, an aggregation score, right, where you have like zero point 0.5 times the BM25 score plus zero point 0.5 times the sentence transformer score, or rank maybe might be a way to like heavily emphasize. So how would the user interface design then take a concept like BM25 sentence transformer and then create an experience in which you can combine them easily for search pipelines?
Yeah, that's super interesting. So first we need to find out like what are all the possible ways that you can combine them. Because the way you just described is like a linear way. So you have you do both searches, so the dense search and sparse search in parallel, and then you do like alpha times the dense, beta times the sparse, and you combine them. So that's a linear way. What you could also do is use RRF methods. And what that means is you take both result lists and you don't look at the individual scores, but you look at the order. So the results that appear on top on both results will appear on top in the final result as well. So these are already two methods of combining the results basically, and maybe there are more. So we need to make sure we first look at, okay, which methods to combine them are relevant. And then secondly, to yeah, support them in a GraphQL design, or like another way of in an API. It doesn't have to be GraphQL maybe. Yeah, that also supports, if there are more methods coming in the future, that also supports like yeah, to be able to scale to that basically.
This is one idea that I think we talked about a little bit recently that I think might be kind of overdoing it. But do you think maybe when you have a query, you kind of classify whether this is a query that should go to BM25, and you should kind of add one more part in the pipeline where the query, what is near text in Weaviate, and then this query intent classifier or pipeline inference thing goes, this is pretty entity centric. We should probably send this to BM25 and weight it according to this function. Do you think that would maybe add like too much to it, or do you think that maybe could just, I guess, coming back to the user experience, it could compress it a lot because you just have this thing that creates the pipeline, and then it's uh, like pipeline wizard or some interface like that.
Yeah, that's super interesting. So I think we're definitely moving in that way, that we like so Weaviate itself is already modular, and I think like the whole GraphQL, or like the whole API, maybe it is not GraphQL, whole API design should also be modular. So I pick this element in my pipeline, this element, I want to combine them like this, and then yeah, and then like you said, like looking at the query, so really query parsing and doing maybe even some manipulation to the query to make the list of results better in the end. Yeah, that I think that's super cool. So if you like, what I saw in research is that BM25 queries, which are very specific, so basically long queries with a lot of entities or named entities in there, they achieve a higher score in the result list than shorter queries or like one-word queries. So if we could somehow learn from a query if it is very specific or not, we can give a higher score to the BM25 compared to the dense methods. And this needs a little bit of experiment, but I think this is definitely the way we're moving to.
Yeah, I really want to dive back into the modular design, but you brought up something that I think is really interesting in that it doesn't always have to be so complicated, right? Like something like just the length of the query could be enough of a
Yeah.
heuristic to tell you which one you probably want to use. I can also ask about the design of the scalar filters, how you can say do a vector search, but then you can also kind of label it symbolically and filter the search that way. How did that kind of come to be in the inspiration of combining it that way with uh, simple kind of filters as well as this kind of vector alignment, right?
Yeah, yeah. So that's really one of the strong points of Weaviate, I believe. So if you just have a vector index or vector index where you can store vectors and retrieve vectors, um, that are basically algorithms like I think like FICE and scan. You can just put vectors in there, but not the data object itself. So if you do, so you can do just a vector search, which means you put a vector as input, you get vectors as output. But that's not really usable if you talk about real data because you want to see the actual data object. So Weaviate doesn't only store the vectors, but it also stores the actual data object, which means, if you search by one, if you search by vector, you can get actual results back that belong to vectors, of course. But then Weaviate also combines this vector search with, like you said, the structured filtering. We call these aware filters. So like in SQL, you can put aware filter. Um, and that so in that you can say some restrictions to your search, some filters. So let's say you want like the color of your product always to be red in the results, then this is a really strict filter. What then happens in a search if you combine this with a near text search? Weaviate will first perform this structured filtering, and it uses like inverted indexes for that. Which then creates an allow list for the vector search. So it's a two-step approach basically. And yeah, I think that's really really cool from a technical perspective, but it's just really um, yeah, it's just something you need to have from a UX perspective if you talk about a database, I think.
Yeah, I think that's huge for the UX of deep learning search generally. If you are getting a nearby shoe image and you can filter it with the red color tag, you already get a much better kind of space of that. And uh, so I see kind of a couple ways of taking this conversation, but quickly I wanted to talk about the idea of just kind of the comparison of face and Weaviate and how you can store the symbolic things. So maybe to give like a quick example of something I've been doing is studying. You have archive title abstracts, and you vectorize the abstracts, and you store the vectors in Weaviate, but then you also store the index. And so what that lets you do is then you want to take the title and see if you can find the matching abstract. And you don't just have the vector because then you don't know if it matched it or not. You also
Mm-hmm.
have the index. So that's like kind of one example that I've been doing that shows how storing the additional things in addition to the vector helps you like study these things. And then also I'd say if the topic is Weaviate versus face, having that persistence of the database layer is super useful for this because it takes a super long time to like upload a million vectors, right? And that
Mm-hmm.
kind of thing. So having it like it's going to stay in there as a database, I've also found that to be incredibly useful. So and then so and I know I'm kind of jumping around with the conversation topic, but so this inverted index thing is like you invert the category so it's red and then the things that have the property red. How does an inverted index and the HNSW index, how do those two things coexist?
Oh, that's a good question. That's really technical. So I think inverted index is something that we know already from relational databases. Um, basically like you said, what you do is you invert the the properties of a data object in the table. So instead of like having each data object with a property and a value, you would have a value first and then each data object that has this value, which that basically just improves the efficiency. Like it has lower latency. I think that whole HNSW is like that's an algorithm, so approximate nearest neighbor algorithm that allows for very efficient vector search. So that's on the other hand, basically. Um, yeah.
Yeah, I think the that approximate nearest neighbor thing is definitely one of my my favorite topics around Weaviate, and I'd love to get back into the modular thing. But can you tell me about your experience with the approximate nearest neighbors, kind of how you first became introduced to it, and then sort of what that unlocks, sort of in your thinking about these search pipelines?
Yeah, so ANN, so let me take a step back. So if you have like a database full of vectors, which are like basically points in a high dimensional space, and you want to search through it, you basically want to do a KNN search, so nearest neighbor search from a certain point, and this point is your search query. So with KNN, you basically retrieve all the elements or all the vectors with data objects that are closest to this search query. And it retrieves, all of them to like how big you want to have it. But if you want to do this on a large scale, and with large, I don't even mean billions or millions, but even thousands, it's really expensive. So the computation time to retrieve those nearest neighbors is really expensive. So that's when that's why ANN, so approximate nearest neighbor algorithms, were introduced. Because if you have like a real-time application with a lot of data, then KNN won't scale. And basically HNSW, so using graphs basically to do this kind of retrieving the nearest neighbors, but like approximately, is one way of doing it.
Yeah, I think it's amazing. I mean, doing the like, I've been doing some tests where I'm doing the exact nearest neighbor, and it really takes a crazy long amount of time to
Yeah, right.
do
Yeah.
the. So I think that's such a huge part of it. And so if we could then come into like the modular design and user experience, and so like one module of the modular design would be these vector indexes, the inverted object indexes for say the color is red, the hospital name is etc, the state is etc, whatever these symbolic filters, and then kind of
Hmm.
going upstream to modules like near text pipelines, question answering, and then also kind of this how this enables the integrations with Jina and Haystack is this kind of modular design, right? And so I wanted to ask about you've made videos on how to add custom modules, and I wanted to kind of ask this topic about the extensibility of Weaviate and adding custom parts to it.
Hmm. Yeah, so I'll first like talk a bit about how this modular design works. So basically, Weaviate itself is a vector search engine, vector database. So without any modules, it's a pure vector database. So that means you need to upload your own vectors with your data and query it with your own vectors. Then you can use, for example, a bioencoder or like a retriever model, like a BERT model, sentence BERT model, or ResNet 50 for images. You can add that as module on top of Weaviate to calculate the vectors of your data and of your search queries if you don't have them yet. So Weaviate offers some of these modules out of the box. So we have our own trained modules, which are very lightweight, but there's also modules like you can use every model that is published on Hugging Face, for example, or OpenAI, which have pre-trained models available to do this kind of inference. And so you can use these modules or these models as a Weaviate module with Weaviate. yeah, then to your question, you can also like not choose not to use any of these pre-trained models, but use a model that you trained on your own or whatever. Yeah, so basically what you then do is you uh, use basically the design of a yeah, if you have text, you use design of a text vectorization module in Weaviate, and instead of um, like talking to this model from Hugging Face, you talk to your own model via API calls.
Yeah, I think that the GraphQL design is so intuitive for how you can chain these things together, and I definitely think that whole thing is really interesting. And so I'm sorry to be sort of jumping around the topics a little bit, but I think so. We've talked about kind of like Weaviate, and I think something that makes it so unique. We have the vector index and how that plays with the inverted object index for adding these symbolic filters. But then one other big part of like the Weaviate data model that I really think is interesting and want to talk about is the graph-like data model and having relations between your data and how you can say, what's the Hacker Noon art? It's wine was made in, and then like a brewery or uh, originally from say France and place like that. So can
Yeah,
you tell me about the graph-like data model and how you can link things? Each thing can have its own HNSW and inverted index, right? With each of the classes that you link together with these cross references.
yeah. So within Weaviate, like the data model works like you have classes, so data classes, which have a name, for example, a wine, and like this data class can have some properties with some values. So property can be, as you said, or like it can be the name of the wine. So you have class wine, and then like a value name of the wine. You have whether it's um, maybe like the type of grapes or whatever, and then but you can also define like where it's coming from, where it's like who is the producer, which color has it. Um, so, but yeah, these properties can be a class on itself. So if you have a lot of wines and you see that the countries, for example, is a limited list, of course. So you can also make a class out of this country. You probably want to do that. Um, so then from the wine, you can refer to which country it's coming from. And yeah, this is basically a graph-like model because you can make cross references between one and the other in a like one-to-many relationship kind of way.
Yeah, do you think maybe we could sort of try to pitch how we could put the Weaviate documentation into this kind of data model? So one way that I like it the most is with this kind of multimodal sense, where say like using the Twitter thing for example, where you have tweet has image, and then so you can separate out the like text vector index with the image vector index. And I also see you
Hmm.
could do that with like code also, maybe like so if we have like a Weaviate in the Weaviate documentation, say there is a tutorial and we want to say has code, has text, and then you have a code vector index. So if you want to search just for a code snippet, you can kind of isolate it that way. Is this making sense how I'm trying to describe
Yeah,
this? Like, could you take me through how you might decompose that data and then organize it in this kind of model?
yeah. Multi-model models are really interesting because what so if a machine learning model is trained on both text and images, they can represent it in the same vector space. This means you can search by one modality, for example, text, and find results in the other, for example, image or code. So um, yeah, this is really interesting because the way we need to vectorize text is like different from like how we look at images. So what is captured in an image? So combining these or in code, so combining these into one model allows us to search through them by whichever modality we want. And this is also something that we can use in documentation later, documentation search, because the way you need to index, like encode text as vector is different from encoding code or images as
Mhm.
vectors. Yeah.
I'm curious what you think of this idea as well. Say we have these, so we have the Weaviate general Slack where we see a lot of these questions about specific things, and say we want to have like a class that is Slack conversations, and then we have another class is the Weaviate documentation, or maybe like a code tutorial that would like walk you through an example of how to use it, and then you maybe link it that way. So it's like Slack conversation, most relevant to documentation, that kind of way of breaking down the data. And then I guess like then thinking about how you can kind of apply the relational filters through it. Does that kind of thing
Uh,
make sense as a way to use the data model?
Um, yeah, definitely. So you could use the questions that are posted in the Slack channel or on Stack Overflow as yeah, as part of your data model, of course. So you can like link those questions with the actual content where the answer is can be found in. Yeah.
Yeah, so yeah, I think that whole thing is really interesting. The all the different parts of the Weaviate model, and then the user experience design, how the GraphQL lets you access these things. I think all that is just really interesting. So, kind of stepping out into more of a meta topic. You've been an avid conference speaker. Can you tell me about like what goes into sort of your preparation, the whole kind of experience? I guess is something I'm curious about as someone who's like kind of interested in doing this kind of thing as well, and like you've traveled all over Europe and in New York, and so like, what has that experience been?
Yeah, yeah, it's been really great. So I'm really happy that we can travel again, like after all the COVID restrictions. So actually, I just started to travel since this year. Before that, I did like a lot of meetups and conference presentations and like workshops online. But I think this whole thing of being in person and being able to actually talk with people, see their responses, like answer their questions and learn about like their interest and motivation, that adds so much value to whatever you're doing, I think. So I think like yeah, I get really excited to speak in front of these people and explain them a really new concept, and then like seeing their reaction. Okay, could actually be something that I can be using, and then talking about like possible use cases and so on. Um, yeah, in terms of preparation, so usually I'm doing like introduction talks to vector search. So what is vector search? Because this is a relatively new concept for most of the people. So yeah, in that case, I have like some slides ready, and then I adjust like the slides to the conference I'm speaking at, to make it like fitting with the audience, and etc. And yeah, I also sometimes give workshops, and then I have like a Python Jupyter notebook ready to share with the audience that they can actually build their own vector search application within the hour, basically. So yeah, that's just super exciting to do.
Yeah, let me ask a quick question on which one do you prefer between the overview or the hands-on workshop kind of thing?
Oh, that's a hard question. Um, yeah, I think the workshop, because I also start with a like a small presentation because I want first the people to know what they are actually gonna do. But then to see the excitement of people that they like do their first neural search, basically their first semantic search, and then like seeing the possibilities that it opens for them is just, yeah, that's really cool.
Yeah, and I think that it comes back to the kind of, hopefully there's a consistent theme. I know we're going around the Weavate topics, but that user experience. And I think there was, I remember reading a TechCrunch article with Bob where it's like Bob put their articles into TechCrunch and then showed them how to do the queries, right? And because that GraphQL design, it's so like you get it right away when you start like using the near text. And I think that really ties the whole thing together with the user experience to putting on the workshop to people saying like, oh, I get what this is, right? And that whole kind of flow of it.
Yeah, yeah, I think that's a really important topic. So if you are using, especially a new technology, like some like new, yeah, new technology, new database, you don't want to be held back by a difficult way of querying it by, for example. So the query language is like the API is the main interface for people. So
Mm.
that is the first thing that we need to like, just like the documentation is, we really need to have that intuitive and as simple as possible. And we also, so that also, so Weaviate has client libraries like in Python, Java, Go, JavaScript, um, so that you can use Weaviate easily within your own applications. And of course, like the team, like Stefan and Marcin, are working on that. So that's also part of the whole developer experience, basically, that we want to have as high as possible.
Yeah, and I also think that that semi console that lets you connect to the Weaviate instance and then do the GraphQL queries without even writing Python code or what. And even in the Python code, I think it's the same thing, right? Where you just have like the three quotation string bracket, and then you just paste in that same GraphQL. But yeah, the console thing, I think that is like a beautiful user interface for getting started with it. Also.
Yeah, exactly. Yeah, and also, so now that the community is growing, we also see that people who are like people start to contribute to Weaviate, but also contribute to examples or like some demo projects that are made with Weaviate. So we see people that made like a really simple user interface for querying images, for example, in a multi-modal way, or a really intuitive user interface for doing it in text, or having a movie recommender or search engine. And I think like if you start with Weaviate and you look at this repository of examples, it's really easy to get started, and that's what really excites me.
Yeah, I mean, I think that's such an interesting part of what we're trying to do with our next, like, few months of doing this is like, how quickly can people learn Weaviate? How quickly can they get their data in? How quickly can they understand how to query it? And yeah, so I think also just the whole thing about content, getting people up to speed with Weaviate. And I think this is like such a great coverage of topics. And I think from everything from the understanding of the GraphQL, the user experience, hearing your story of the time at Weaviate, and design of modules, extending it with other plugins like Haystack, Jina, Hugging Face, OpenAI, and how this whole thing fits together. I think this was a great overview. So thank you so
Mhm.
much, Laura, for coming on the WeVA podcast and explaining these things.
Thank you, Connor, for having me. That was great.